Hello and welcome back to FIGS in the Shop, where we're doing part 2 of our machining operation on our stainless steel taper stud for dropout or tie rod ends. And we're going to be adding that front profile to the previous operation, which was just a shank thread and profile. And so now we're going to be adding a taper, and then we're going to be cutting some metric threads on the end of that. So this is how we're adapting between a ball joint and making it so that you have a bump steer adjustable rod end that can mount into the steering connection. Now this is a two-tool operation, so we just have a profile cutter, which is a CNMT carbide insert on the cutter that's active right now. And then we go to a Coro thread threading tool, which is actually a boring bar that we're using for exterior threading. It's actually intended to be an interior thread tool by just the angle that the insert is angled at, but with a little bit of a trick in lining up the presentation of that tool, we can use it for cutting exterior threads, and it actually does a really good job. Plenty of coolant here, and I'll just let the machine do the talking, and I'll add a little bit of input as I see there's something to explain. So I guess the first thing I'll mention is, why is the taper so important? And what are the differences between different ball joints? Well, we probably got, I think, 8 or 9 different taper studs, if not more. And while some of them share a similar angle, they have different termination diameters. They might just be off by 1/2 degree. And the difference between 1/2 degree in a tapered connection means that it can wobble. And as it wobbles over time, it's going to enlarge the hole that it's in. So we take designing these taper studs pretty seriously. It starts with a 3D scan. Then we take that scan data. It's not automatic or anything like that. We got to extract the geometry from the scan, and then we're going to model a new part after that taper. And then from that new part, it may take a couple times to get the engagement exactly where we want it, to mimic where the factory ball joint is. And then we're ready to, do something like this, where we're actually physically making the part in CAM. And this is the final finish pass over the taper profile. This is just before we're going to start threading with our single point metric M12 Sandvik Coromat threading tool. So it's going to take 18 passes to plunge to a depth of about 40 thousandths of an inch. And you can see those passes are pretty rapid, but each one is synchronized, so it's progressively pushing that thread depth down to the final depth. And there we have it. And this is another wide-angle view of the lathe doing its thing. I thought it was pretty cool just to show the overall envelope of the machine and how it's really moving around, its rapids, etc. So I sped it up on this particular video, unlike the last one, just to condense time. But if anybody has any questions about the setup, or anything about machining, feel free to comment below this video, and I'll try to address those as they come in. So going back to the CAM profile and how we generate this code, we're using a CAM package out of Fusion 360. It's an Autodesk product. We design our parts in SolidWorks, and then we import it into Fusion 360. And we're making these CAM paths pretty iteratively, so it's going to come down to how much material you're taking off per pass, what the manufacturer's recommendations are for a particular cutter, and calculating speed and feed to get the finish that you want. So there actually is quite a bit of work that goes into setting up one of these parts to be manufactured. And we may scrap 1, 2, 5. It just depends on how bad the scrap is, and as we're making these profiles, what the challenges are. And the final test is threading on a nut, seeing how the thread profile matches up with the nut that we'll be using. And there's still a few extra steps to do on this stud, so we'll probably do a third video where we show it in place and final verification. Thanks for watching. Follow us if you want to see more videos like this.